Hey guys, this is video 10.5. This is how we're going to determine the molar mass of a substance. Okay, this is related to the ideal gas law. So what we talked about in the last video in 10.4. So this equation is derived from the ideal gas law. This is one that's not as common, so don't worry about the derivation. It's something we can talk about if you take AP Chem. But for now, I'm just going to give it to you so that we can see it. Kind of an extension. Do I anticipate you seeing this on the Regents? Probably not, but you very well could. So another formula that you probably want to write down on table T. Okay, and then define all those things as well. So take the next minute or so, jot this down on table T. D equals PM over RT, and make sure you define it. D is density. P is pressure, again in atmospheres. Molar mass, we get this from the periodic table. That's what PT stands for. Constant is that R constant. Make sure you have that memorized and have it on your table T so that you have it. And then temperature is also in Kelvin. So again, you're going to be given all of the variables except for one, and you've got to find that missing one. So let's jump into an example. We are looking for D, which is density. We have C4H8 at this temperature, so T is 273 degrees Celsius. So again, add 273 to that to get it to Kelvin. When we do that, it's 546 Kelvin. Our pressure is 2 atm, and that's all I'm given in terms of numbers here in this problem. So if we're looking for density, we know that D equals PM over RT. Well, R is a constant, 0.821 latum over molk. So now we still need M, guys. Molar mass. Are we given anything here in this problem that's going to help us get the molar mass of this substance? Yes, we are. We are given the formula. So again, this is a review. We're building on what we've already learned. You should be able to recognize that at this stage in the game, that, hey, I can just go to my formula and get the molar mass. So I've got 4 atoms of carbon times 12 for its molar mass, plus I've got 8 times 1 for hydrogen. When I add that all together, guys, my molar mass is going to be 56 grams per mole. Okay? Now it's just plug and chug. D equals P, my pressure is 2 atm, times my molar mass, 56 grams per mole, all over my R, 0.0821 latum over molk. And then times my temperature of 546 Kelvin. So K's will cancel out. Moles are going to cancel out. Atmospheres are going to cancel out. So I'm left with just grams per liter, which, if we think about, is a perfect unit for density. Mass per unit of volume. So now we just have to do the math. Top times top, divide by bottom, divide by bottom. When you do that, so I know I'm giving you the answer right here, guys. It's an example problem, but you need to be able to plug this into the calculator. So I encourage you guys, do the math to make sure you get the same answer that I get. I got 2.50 grams per liter. Okay? So just remembering, you got to make sure your units are appropriate, and then it's just solving for the unknown. So I want you guys to try this. Pause this video right now, and you try the last problem here. All right, so we are given the density this time, 1.853 grams per liter. We have a pressure, but notice our pressure is in millimeters mercury, 745.5. We've got to get that to atmospheres, divide by 760. When we do that, you should get 0.98 atm. We have a temperature, that's Celsius. Add 273 to it right away, 296.8 Kelvin. We are looking for the molar mass. Okay, R again is our constant, 0.0821 latum over molk. Now, this one's a little bit more challenging to kind of clear to get our unknown by itself. So I've got D equals PM over RT. Well, I got to clear this fraction, so cross multiply. Okay, this times that's like over 1. So really what we get here is DRT equals PM. Now we can get M by itself. Divide by my pressure. Those cancel out. So I get molar mass equals DRT over P. My density, we said, was 1.853 times 0.0821 times 296.8. all over my pressure, which is 0.98. I've ran out of room here, guys, so I'm going to kind of draw an arrow up to this space if this wants to work. So equals, my answer is going to be right here. You should get 46.1 grams per mole, and units matter. You got to make sure you have the appropriate units. If you had issues, guys, with any of the problems that you've done, as always, raise your hand and call me over. I can come over and help you. Excuse me, but now you are good to go and practice the next page. Do practice number 3, ideal gas law practice. Remember, make sure you can either use PV equals nRT or the density formula. Use atmospheres, liters, moles, and K. And then your R value is that. So you have to be able to figure out what formula you need to answer, and that's what we'll be practicing in this. All right, if you have questions, let me know.